Hello students, let's discuss new chapter wave optics. We have already discussed ray optics. Now here in this chapter we have to discuss wave nature of light. The first question is write note on wave front. Okay. So what is wave front? The definition. The imaginary surface. The imaginary surface passing through the particles oscillating in same phase is called wave front. Okay, so wave front is a surface, the imaginary surface passing through the particles oscillating in same phase is called wave front. Okay. Speed of the wavefront is speed of the wave. So motion of the wave can be explained by the motion of wavefront. Clear? Speed of the wavefront is speed of the wave, okay, in given medium. So the motion of the wave can be explained by the motion of wavefront. Okay. Now listen. If the medium is homogeneous and isotropic, then the wavefront has regular shape. ठीक है. Otherwise it has irregular shape. If the medium is homogeneous and isotropic, then the wavefront has regular shape, otherwise it has irregular shape. Now homogeneous means all properties are same at all points of medium. All properties are same at all points of the medium, then it is homogeneous medium. And if all properties are same in all direction, it is isotropic. Clear? Homogeneous means all properties same at all points, and isotropic means all properties are same in all direction. Okay. Now listen. If the medium is homogeneous and isotropic, then there are three types of the wavefront. If the medium is homogeneous and isotropic, then there are three types of wavefront. First is spherical wavefront. The first one is spherical wavefront. Okay. In this case, listen. If the source is point-like source, if the source is point-like source, in that case, if the source is point-like source and medium is homogeneous and isotropic, in that case, at any given instant of time, if we consider points at equal distance from the source, okay, the phase must be same. So the surface passing through them is your wavefront and it is spherical in nature. Okay, इस तरह से सपोज ये पॉइंट लाइक सोर्स में से जो वेव्स निकल रहे तो इक्वल डिस्टेंस पर फेज सेम होगी एंड सो द वेवफ्रंट इज स्फेरिकल. But if the source is point like source, then the wavefronts are spherical in shape. Second, cylindrical wavefront. Cylindrical wavefront. Okay, so here listen, if your source is linear, okay, if the source is linear, in that case at any instant of time, if I consider the surface at equal distance from all points, equal distance from this linear source, so it is cylindrical in shape और वहां पर फेस सेम होगी. तो ये जो आपका सरफेस है, ये जो आपका सरफेस है वो आपका वेवफ्रंट है. बराबर. तो अगर सोर्स लीनियर है तो उस केस में मैं लीनियर सोर्स से इक्वल डिस्टेंस पर जितने भी पॉइंट्स है बराबर वहां पर फेज सेम होगी. बराबर. तो उनमें से पास होने वाला जो सरफेस है वो सिलिंड्रिकल होगा. तो इस तरह से मुझे वेवफ्रंट सिलिंड्रिकल मिलेगा. ठीक है. तो if the source is linear, then the wavefront is cylindrical in shape. Okay, and the third one is plane surface, plane wavefront. Now remember, there is no specific source for plane wavefront. But normally the wavefronts are either spherical or cylindrical. But when spherical and cylindrical wavefronts are obtained at very large distance, so locally they are plane. Clear? When spherical and cylindrical wavefronts are obtained at very large distance, then locally they are plane. For example, suppose ये sun है और ये earth है. Now if I consider sun as a point like source, okay, तो sun में से जो spherical wavefront प्रोड्यूस हुआ, तो उसका very small part अर्थ के कांटेक्ट में है, तो we can consider this part as a plane. Actually it is the part of spherical wavefront but locally it is plane. ठीक है, अगर हम फुटबॉल ग्राउंड पर हैं तो it looks plane, बराबर, but it is the part of spherical surface. So similarly when spherical or cylindrical wavefronts are obtained at very large distance, locally they are plane. बराबर, म्यूट, इसे पॉज करो, रीड करो, नोट्स बनाओ. नोट्स की पीडीएफ भी मैंने अलग से फोल्डर में रखी हुई है. Now let's discuss Higgins principle. So what is Higgins principle? So each point on given wavefront behaves like secondary source and emits spherical waves in all directions. Clear? Right. Then after small time interval, a surface which is tangential to spherical wavelets of all points on wavefront gives position and shape of new wavefront. ध्यान से, each point on given wavefront behaves like secondary source and emits spherical waves in all directions. After small time interval, a surface which is tangential to spherical wavelets of all points on wavefront gives position and shape of new wavefront. तो इससे क्लियर है, ये जो लास्ट सेंटेंस है कि ह्यूगेन्स प्रिंसिपल, मेरा this principle gives position and shape of new wave front. बराबर, suppose xy is wavefront at time t is equal to t. Now according to Huygens principle, Each point on this wavefront behaves like secondary source and emits spherical waves. Okay, so A, B, C, D, E, F, G, H are the points on this wavefront at time t. We know that the direction of rays is always perpendicular to wavefront. Okay, so these are the rays passing through point A, B, C, D. Okay. Now suppose we are interested to find position and shape of the new wavefront at time t plus delta t. So the time interval is delta t. If the speed of the wave in the medium is v, in that case distance traveled is v delta t. Okay. Now in case of spherical wavefront, distance traveled by the wave is radius of the wavefront. So considering A, B, C, D, all these points as a center, construct spheres of radius v delta t. Okay, so suppose these are the spheres of radius v delta t. Considering A, B, C, D, all these points as a center, construct spheres of radius v delta t. Now the tangential surface to all these spheres is your new wavefront. So x dash y dash is new wavefront at time t plus delta t. Clear? So suppose xy is the cross section of spherical wavefront with plane of paper at time t. Bruh, A, B, C are points on this wavefront which behave like secondary source and emit spherical waves. Here spherical waves का मतलब है जिनका वेवफ्रंट स्फेरिकल है वो. बराबर in delta t time interval distance traveled by the wave is v delta t. Okay, thus considering points A, B, C, etc. as center, construct spheres of radius v delta t. Tangential surface x dash y dash is new wave front at time t plus delta t. ठीक है, तो each point on given wavefront behaves like secondary source and emits spherical waves in all directions. After small time interval, surface which is tangential to spherical wavelets of all points on wavefront gives you position and shape of new wavefront. ठीक है, तो अगर आप अब आपको समझ में आ गया होगा, ए बी सी ये पॉइंट्स है जो सेकेंडरी सोर्स की तरह बिहेव करते हैं, स्फेरिकल वेव्स प्रोड्यूस करते हैं. अगर मुझे डेल्टा टी टाइम बाद का वेव फ्रंट चाहिए, in that case the distance traveled is v delta t. Distance traveled by the spherical wave is actually radius of the spherical wavefront. So you have to consider ABCD points as a center and construct spheres of radius v delta t. And now the tangential surface x dash y dash to all these spheres is your new wavefront at time t plus delta t. नोट कर लो, ध्यान से एक बार पॉज करके फिर से पढ़ लो. Next question, we have to discuss Doppler effect for light. We have discussed Doppler effect for sound in 11th standard. Okay. Remember, Doppler effect is the phenomenon of frequency. So you will find Doppler effect where frequency is associated. Okay. So Doppler effect, it is the phenomenon of the frequency. Now the definition. When the source of the light and the observer are in relative motion in stationary medium, frequency experienced by the observer is different than the frequency produced by the source. Clear? This phenomenon is called Doppler effect. Clear? When the source of the light and observer are in relative motion in stationary medium, तो क्या होगा? Frequency experienced by the observer is different than the frequency produced by the source. This phenomenon is called Doppler effect. ठीक है? Now suppose the source of the light moves away from the observer. Okay. In this case, the distance between two consecutive wavefronts near the observer is greater than near the source. Okay, so the frequency experienced is smaller than the frequency produced. ओके तो इस केस में फ्रीक्वेंसी कम हो रही है, डिक्रीज हो रही है, बराबर. व्हेन frequency decreases in spectrum of the visible light, the line shifts towards red color. So this decreasing frequency is called red shift. ठीक है, लिसन. सपोज ये आपका सोर्स है और ये ऑब्जर्वर है. अगर सोर्स ऑब्जर्वर से दूर जा रहा है तो सोर्स जो वेवफ्रंट प्रोड्यूस करेगा, मेरा ये वेवफ्रंट जब ऑब्जर्वर के पास पहुंचेंगे तो कंसेक्यूटिव बराबर जो वेवफ्रंट्स होंगे उनके बीच का डिस्टेंस बराबर ज़्यादा होगा. अब ये जो कंसेक्यूटिव वेवफ्रंट है उसके बीच का जो डिस्टेंस है उसे आप वेवलेंथ कंसीडर कर सकते हो. यानी ऑब्जर्वर के पास वेवलेंथ ज़्यादा मिल रही है. वेवलेंथ ज़्यादा मिलेगी तो फ्रीक्वेंसी कम मिलेगी. ठीक है, तो फ्रीक्वेंसी आपको कम मिली बराबर. तो इस केस में फ्रीक्वेंसी जो एक्सपीरियंस फ्रीक्वेंसी है इट इज स्मॉलर देन द प्रोड्यूस फ्रीक्वेंसी. ओके, एंड सो इट इज कॉल्ड रेड शिफ्ट. क्योंकि जब आप रेड कलर की ओर जाते हो तो वेवलेंथ इंक्रीज होती है और फ्रीक्वेंसी डिक्रीज होती है. सिमिलरली व्हेन द सोर्स moves towards the observer, तो distance between two consecutive wave fronts and observer is smaller than at source. So frequency experienced is greater than frequency produced. This increase in frequency is called blue shift. बराबर. अब ये जो चेंज इन फ्रीक्वेंसी है तो डेल्टा एफ बाय एफ इज माइनस वी रेडियल बाय सी. इस फॉर्मूला से आप इंक्रीज इन फ्रीक्वेंसी फाइंड कर सकते हो. बराबर. यहाँ पर वी रेडियल क्या है? इट इज component of velocity of the source in the source along the line joining the source and the observer. बराबर। अब ये जो फॉर्मूला v इज इक्वल टू लैम्डा एफ, तो इससे बराबर इसका अगर आप डिफरेंशिएशन करते हो तो यू विल गेट डेल्टा एफ बाय एफ इज माइनस डेल्टा लैम्डा बाय लैम्डा। सो thus डेल्टा लैम्डा बाय लैम्डा इज v रेडियल बाय c। तो इससे आप चेंज इन वेवलेंथ फाइंड कर सकते हो। ठीक है, पढ़ लो ध्यान से।